Here we go. Let's see. Okay. There's no one here yet. Okay, we will start here in just a few minutes. Can everyone, let's see. Can anyone hear me? Coolio. Let's see. We will get started here at 4. Hopefully a few more people will show up. There's supposed to be like 30-ish people. Awesome. Okay. Okay, let's see. It's lagging behind a little bit, but that's fine. What team are you on? Just out of curiosity. What's up, Braden? There we go. Lamau. Okay, 2 minutes, and we will get started. So I'll pull up stuff on my phone so that it's a little bit easier to follow. And I do apologize. I was going to get actually a digital doodle board so that I could write like a virtual whiteboard essentially. But my laptop had issues, and I have been waiting for them to send me a replacement, and they are still not sending me a replacement yet. So I should get that later this week. But I bought stuff to make a virtual whiteboard and shipped it to my house. But I'm still at college until um, tonight, and I won't be able to use that until my new laptop comes. So about one more minute, and then we will get started. There we go. We got some people here. Awesome sauce. It is 4. I'll give everyone about one more minute to kind of get in. Um, Apologize for the lag, but luckily everything here is powered by Google, so I appreciate that all the software is free and makes this possible. Because I don't know, I was thinking about this the other day, and I thought it was pretty cool that we're able to have people from around the world participate as though they were here in person at their own convenience, and all of this is free and accessible. So, oh, what's up, 323V? Cornerstone represent. I'm going to go ahead and get on the forum and throw the link on there too. I guess can't hurt. Okay. Let's go ahead and get started, I guess. Let's see, where's the... Yes, I was on 323Z. For 2 years, I was a founding member of 323X, and I was great friends with everyone on Z because we had practice together. And so then the next year, especially just because I had put in a lot of time and gotten really close with some of the Z guys, ended up going to 323Z for my last 2 years. Worked very closely with Jesse, and pretty much all of the founding members my second year, and then the third year I actually led 323Z as we went through the Nothing But Net season. Um, so yes, I was on Cornerstone. Let's see, where's the... Oh, I closed live stream. How many people we got? Okay, we got a few people. Then I guess we will go ahead. 323Z does not still exist. It was dissolved after our final year just because it was a legacy team and had been very involved in the community, recognized nationally and internationally. And everyone on the team just really wanted to kind of let it be more of a memory just because it had been, for everyone on our team and in the club, it had just been something that we had really dominated our lives. And it was just such a huge part of that part of our life that we wanted to kind of keep those memories, and not so much, and focus more on mentoring for the next generation, doing things like this, or as Jesse and others have mentored many teams, I've been involved with advising many teams, more just focus on the future and keep the memories, but not try to keep it more as a memory rather than something that is continually being, I guess, updated and regenerated, and also give, um, also to challenge newer members to try to. We wanted new members to get involved in building their own YouTube channels and have lots of people who were um, contributing to the Vex community, and not just, uh, I guess, kind of going back to the same YouTube channels and the same stuff just because it had been around, but get people to think, oh, what can we do to really reach out to the community? So we're a few minutes past 4, so I'm going to go ahead and get started. We have, yeah, we have a few people here. Inception again. So anyhow, I'm going to introduce myself. My name is Luke, Lucas Roller, actually, but everyone pretty much calls me Luke unless I'm in trouble. Um, I mean, that goes for everyone. So during the first lecture, we're going to cover a lot very quickly. That's kind of why I threw the lecture notes out earlier on, was because I wanted everyone to have an opportunity to check everything out ahead of time if there was any of the topics that you weren't already familiar with, because many of these things, well, some of this should be new information, many of it's not, I guess, pinnacle, and much of it should also be review. And so I want to do kind of a quick overview, and the goal for today is to get to the end and start dealing with some scanf and printf functions, which, like I said, we'll get into. But getting there, there's a lot we have to cover between now and then. So anyhow, like I said, I am Luke. I was on 323Z, as I said, in the 323 Club, Cornerstone Robotics, for 3 years. I was on 323Z for 2 of those. My first year was on 323X. Um, I mentored 323M, the Shadow, and worked very closely with also 323V Vortex, which was an IQ team. Shadow was and is an IQ team. And also 323S Skyhawk. Um, so shout out to them because they're all a bunch of great teams that have done amazing things. 323S winning the world championship last, or was it 2 years ago? I guess it would be last year, correct? Um, so shout out to all of them. They still inspire me, honestly. I saw some of their robots recently, and not only just as what they build, but also like their teamwork and them as engineers inspire me that the next generation of Vex engineers and engineers in general are going to do amazing things. So on to the actual lecture. I have a tendency to get on side tangents. I want to real quick touch that Robot C is a C derivative language, meaning that Robot C is C programming language. So ASCII C99, which we'll get into the history of C and exactly what that means, is very, very similar to Robot C, and really the only difference with Robot C is that it has a compiler specifically meant for the platform of being on the Vex Cortex, which again, we'll get into what all these terms mean. If you are not familiar with it, don't worry. We will cover all of this today in a way that will give you at least a good overview of the topic. So the reason I bring this up is Robot C is very similar to C. It really, truly is C. And so rather than developing in specifically Robot C, I want to show that C itself, which we will be, I threw the link into the course resources page, so look for that there, online C compiler. It should be this, jdoodle.com/C online compiler. What we're going to do is work in developing in C, because it is, in fact, Robot C. Robot C is C, and they have while there's some specifics that have been included into Robot C specifically for the VEX platform and for robotics, you have to understand C programming, functional programming, the concepts of that in order to effectively program your robot and not just be doing plug and play, essentially, copy paste and then changing numbers and, maybe a few variable names or whatever. But to be able to actually build something for yourself that will be able to, really control your robot and do cool things. So first point, Robot C is C. C is what we're going to be focused primarily on learning. And then as we get farther into it and more advanced towards the end of these 3 weeks, then we will get into some more Robot C specific things and also um, programming the robot specifically. So what is functional programming? And you might have heard the term object-oriented programming before. So how are they similar? How are they different? So again, I don't claim to be an expert, but I do know enough to talk about the topic a little bit, touch on it a little bit, and so that's what I'm going to try to do. So functional programming is a programming method or pattern. It is a style of building the structure and elements of computer programs that treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. Data will not change even though the values contained in that data may. So to kind of sum that up very quickly, functional programming is a structure for programming where everything is dealt with in numbers. So everything is a number. When you have a variable, it's a number, which is represented by the address where that number is stored, which is also a number. Everything is number. It are numbers. When you evaluate logic, true, false, it's always numbers. It's always ones, zeros. Everything comes down to binary, essentially, which then propels us into our next topic, base number systems. What is a number system? So we're going to be converting back and forth for number systems much of the time. Number systems were developed quite some time ago, the most common being the base 10 number system that we are all familiar with, or decimal. And that was introduced to the Western civilization approximately 900 years ago. But what made it um, so key in propelling forward mathematics and science and everything that has given us the world we live in today is, so how many fingers do you have? We all have 10, right? And so it's very easy to grasp the base 10 number system because it's based on something that is a shared common experience between virtually all of humanity. You can count up to 10. And so, there's this very fundamental idea of, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so while base number systems, that is the most common one, it's not the only one. There's binary, octal, decimal, hexadecimal. In fact, number systems by definition of this type can have any base number. You could have base 234, and it will be able to represent any number that you can possibly come up with just as effectively as decimal or binary or anything else. So I pulled up an image here because, like I said, I would love to diagram this out, but it's a little bit hard to do at the moment just because of what I have available to me. But base number systems, you have your base number here, so 10 or 2 are the two examples given here. And each place, so just like you would have here, your ones place, right? Your tens place, hundreds place, thousands place. If you look at this as a system, if you use powers from math, 10 to the 0th place is 1, right? 10 to the 1st power would be 10. 10 to the squared would be 100. 10 cubed is 1,000, etc. The same exact thing for binary or base 2 or octal, base 8, hexadecimal, base 16. All of these have a base number raised to a power, and each power is the place of the number contained in there. And so the number contained in there is then multiplied times then the base number to that power. So 7 times 10 to the 0th, or 1, 7, plus then the next one. So you add each of them, multiplied times then the base number to the power of that place. So I will find an online worksheet and throw that in there for anyone that might not already be familiar with this and would like to learn about it. Same thing for binary. If you want to represent the number 45, here, as you can see, it's all ones and zeros. So I guess that's another topic I should quickly touch on. When you have a base number system, the maximum number that you can have in any given place will be one less than the base number. So if you have base 10, it will be 0 through 9. If you have base 2, it will be 0 through 1. If you have base 8, 0 through 7, it contains 8 numbers, but it is exclusive of that number, meaning it is inclusive of 0 through excluding that number. So 0 through 9, 0 through 1, 0 through 8, what have you. Like I said, I'll throw in a worksheet or something for that, so it's a little bit easier to grasp if you're not already familiar with this. And then also quickly, here's another example of this. If you would like to pause the video and look, this also makes it very easy to understand. So back on topic for the lecture. So we've covered base number systems now, and next, or also I should also touch, if you're not familiar, hexadecimal or base 16, you can only have 0 through 9, right? But if it's 16, it's got to be 0 through 15. The way that is represented is it also uses letters. A represents 10, B represents 11, C represents 12, D represents 13, E represents 14, and F represents 15. So while it is numerical representation of the concept of a number, sometimes you also then get letters thrown in there. But they also represent numbers. So how does programming make an output? Well, there's two basic types of languages, compiled and interpreted languages. I also came up with pulled up a couple of definitions for this. A compiled language translates the meaning of code into machine code before it runs. They're typically faster. C and robot C, which is, as I touched before, C derivative, are two of many compiled languages. So compiled languages are put into the interface that humans see, the actual code, and then they're translated then into the machine language, the language that the computer understands before it runs. So because it is doing this before it runs, it is already in that machine language. That's why things like in the earlier definition of typically avoiding mutable data, i.e. data that will not change, even though the values contained in the data may, it will not just define new memory. Like I said, we'll get into what all these things mean eventually, but I'm trying to do a very quick overview. So if you are a little bit lost, don't worry about it. If you're tracking, awesome. So it will avoid creating new memory, assigning new memory midway through, just because it's compiling the entire thing. It's setting everything up to just change values and run calculations prior to running. However, an interpreted language is a little bit different. While everything does eventually end up into machine language, the way it gets there is different. First, it translates the meaning of the code into machine code in real time while the program runs. This happens because an interpreter program breaks each statement into one or a series of subroutines that have already been compiled into machine code. So if you think about it this way, if you had, say, clay, and you made a statue of something, you wanted to make a statue of yourself. You wanted to make a model of your head. A compiled language would do that by clay, where it gets the entire thing done beforehand, and yeah, it might not be quite the right color or whatever. You need to add some hair or what have you to the top of your head. You might need an extra ear or something, I don't know. That would happen all before you ever get to, painting your statue. An interpreted language is where instead of seeing it as this, block of clay, instead it's going to see it as like a bunch of Legos, and it's breaking that shape into a bunch of little different blocks that then the interpreter program, as it sees each statement, each concept, it's breaking that into those little subroutines and putting them together to get the code. But because it's having to do that process of breaking it down, it's going to be slower than a compiled language. And it's also going to, but it's also going to give some flexibility because of that, because you can all of a sudden just pull in another element. It gives you some more flexibility as well. But for C, or C derivative languages as robots, C in our case, or pros if you use pros, compiled languages are what we're dealing with. So what's the compiler process? Since that's what we're concerned with, what is the compiler process? So thanks to nerdyelectronics.com, I found this wonderful graphic that really helps to make this easy to understand the process. This is something you might want to refer to later, just because I know for me, when I first saw this, and much of this is college level stuff, like this is stuff I had in my classes this year and last year. It made the whole process a lot easier to understand. So when you're trying to figure out bugs in your code or trying to design something, this can help you understand why different things go different places, why they fit together a certain way, and makes it just easier to understand. So what we have to worry about, the only thing that we see as users is going to be the editor or IDE, and then output, the input output. Those are the only two things we directly touch. The editor is where we're actually typing in the code. So for much of what we're doing is going to be something like this. It's going to be where we're actually able to type in things. So like, if we wanted to say instead, let's make this x times y. Change this to x times y, print it out. Then we're going to be able to execute the code and see that 10 times 25 is 250. And this is going to be our output. So this is where we're editing everything, and this is where we're actually seeing what's happening. So after that, we come to the preprocessor, the compiler, and the linker. This is where the program is actually built. This is where it's run, but this is where it's built. So we touch it when we're making it, and then when it's actually executing. But all this other stuff in between, we don't touch. So, or at least for this kind of programming. Someone does, but it's not us. So for the preprocessor, this is where it includes files and replace symbols. So if you see, or the preprocessor where it pulls in source codes, headers, all that stuff. So if you see here that there was a library included, a standard library, the standard input output, stdio.h, hashtag include that, that is then pulling in, right in this step, that .h file. So if we then at the compiler level, it's taking those included files, rolling them in, so it's replacing functions like the printf and stuff with then the code that's the code behind it that makes it be able to actually print this. Then on the next step, or the included files, and also replacing symbols. So let's say we had like a constant variable. Again, if there's any terms or anything that you're not tracking with, do not worry, we'll get to it. It'll replace those with those numbers and then roll it all together. Object codes, all that stuff. It's all getting rolled together in these three steps into something that's actually executable. Then after it's built, you get an executable file, at which point it is able to be run. Loads in shared libraries, loads the code, you do your input output, and it actually executes and runs the code. So now that we have a very, very quick overview of the compiler process and how everything works, also want to touch on computer memory. Memory is physical space on a hard disk drive or solid state drive made up of bits, with each bit representing a 1 or 0, because the computer deals in binary. 8 bits are combined to make 1 byte. Each byte has an address and has a value. Different data types use different amounts of memory, and their uses are chosen based on the task trying to be accomplished. And each byte has an address. So why this is extremely important, excuse me, why this is extremely important is when you're dealing with memory, when you're dealing with bugs, you always need to remember that you are dealing with physical space. This is not just a completely abstract, um, concept. This is a legit place in space that we're dealing with. So it makes it a little bit easier to kind of wrap your head around. So the history of the C programming language, and to real quick answer your question, it'll be roughly an hour. It is moving really quick, like I said, and we're covering a lot. But by the end of this, it'll put us into a very, very good position to be able to actually get our hands dirty and do some real programming the next time. So stick with me. If you need to go, that's fine. The stream will be posted on YouTube afterwards, so don't worry. History of C programming. It was originally developed by Dennis Ritchie and Ken Thompson in 1972, 1973, starting 1972, completed in 1973 with the original version. Um, it was very popular right away just because it is a very powerful language, but it's also very easy to get started with. One of the reasons why it still is in such widespread use, and also why it's a great language to learn, because it gets you involved in functional programming very early on at a very easy level, but it is also one of the most powerful languages in the world because you are able to do so much. Entire operating systems have been built in this language. Windows has been built in this language. Unix built in this language. You can do so much. It's incredibly powerful. Um, we'll be dealing the American National Standards Institute, or ANSI, formed a committee, standardized the language, with different versions released in 1989, 99, and 2011. Pretty much the standard is C99, and I believe that is the version that we're dealing with here. So to continue on, variables and constants. This is getting into a little bit of the real programming, as I said. Variable is an element that can be changed. In programming, it is referred to by a symbolic name or an identifier. That is a key term. Let me even highlight that, because that is a term that you want to remember. It's a technical term that when you're uh, speaking with people, whether it's to get an internship or whatever, that is, um, you need to definitely know that term. And represents a place or address in memory. Like I said, that physical place. The first letter of the name should be lowercase, and there should not be uppercase. This is pretty much the standard. There are other standards where it would be like where it'd be something like distant to fridge. But if you see, that's just more difficult to read than this. And so yes, this takes a little bit more effort to be able to put an underscore, but I would, that is the standard we're going to deal with, just because it is good programming practice. And much of this really comes down to good practices make it very easy to program and program well. So here's a couple examples. So this would be the data type, int or integer, only whole numbers. Distance to fridge would be then would then be the identifier or the name, which represents, like I said, a physical place in memory. And then you can store any number in there, and you can change it because it is variable. It does not have a static value. You can change it. A constant is very similar to a variable in that it has an identifier, and that has, I don't want to say an address in memory because I don't know. I believe it's actually not an address, but instead, when it's in the compiler process, as I said, it replaces constants, I believe, but I don't want to be held to that just because I don't want to give you any misinformation. But it is very similar in that from a programmer standpoint, it has an identifier, and that identifier represents a number then. So a constant is an element that cannot be changed. It's referred to by a symbolic uh, symbolic name or identifier, and I'll need to double check that this is correct. the entire name should be capitalized if it is a defined one, or there can also be another one called enumeration. That's a little bit more advanced, and we'll get into that possibly later on. But this is pretty much the standard way to have constant. There's also something called a literal constant, and a literal constant is, so if we're going to say, like, say circumference, we'll say that we have a variable called circumference. We would do circumference is equal to then diameter times pi. If we put in 3.14159, this would be a literal constant. It's because it is literal constant. And that is, and this means it's a comment, so it would ignore this if we were compiling. A literal constant is literally just a number. It's like if you had 5 or 3.14159. It's just a number, but it's because it does not change. It's a constant, and so the technical name for that is a literal constant. So variables can be defined as one of many different data types. A data type determines the amount of memory allocated to the variable and the way in which the computer interprets the binary number stored in the address. So again, remember, everything in this language is numbers. And so an integer is nothing more than a binary number in the address. Double, nothing more than a binary number in the address. How it interprets that is determined by the data type that you define it as. So after you, because it's an interpretation of that memory, it can't just change that midway through. And so once you define a variable, it will forever be that data type, if that makes sense. So data types, there's many different types, the main ones being integers, and then different floating types or floating point types, meaning just decimal point where you have a number after. Then there's signed, unsigned, where it can be positive and negative or just positive. There's all those, but these are kind of an overview of the main ones. So is everyone tracking pretty well? That's actually a very interesting point. I feel like you could make an argument that DNA is, I feel like it would be more like interpreted, but that would be, I don't know either. That's actually a very interesting question. I will look that up. So going on to ASCII standard. ASCII, or ACII, stands for the American Standard Code for Information Interchange. All data types store a number, and the same number can be interpreted a variety of ways. So going back to what I was saying, everything is this binary number stored in a physical place in memory, right? Doesn't matter if it's a letter, doesn't matter if it's a number, doesn't matter if it's a decimal, it's always going to be stored as a binary number, and how it's interpreted is comes down to literally just how you define it to be interpreted. So even letters, even characters, are all nothing more than numbers. So this is not an entirely complete table because there are different characters, even if it's like an enter and other stuff. There are characters here that represent 0 through 31. So I apologize for this being not entirely complete. I will post something. I know it's on an ASCII table that is in one of my courses from university here. I'll post it at some point. But like I said, so here's the decimal, hexadecimal, octal, and the character. So if you were to printf, like I said, so this one here, %d means it's an integer that or a whole number rather, %d. So because this is an integer z equals x times y, then that is going to be printed as an integer. So let's see, this printed as being 250. So we're going to see that there's no 250 here, but let's say 150 is lowercase, or excuse me, no, that's octal. So 100 is a lowercase d, decimal to octal. So let's say here we change 25 to 10. So let's see what this is going to print. Execute the code. Sum of x times y equals %d of z. Z, as we can see here, equals x times y. X equals 10, y equals 10. 10 times 10 is 100. So z is going to equal 100, prints 100, and we can see here that is confirmed. But because we're printing it as a integer, it's printing an integer. But if we go back here again, see 100 is a decimal. But if we look across here at a character, it is a lowercase d. So the character to print, character is %c, and this is not good programming standard, because this is, we'll get into it later, but it's essentially converting the data, how the data type is interpreted. So it's dangerous to do from a computer standpoint, but let's see what it does. See here, it now prints a lowercase d because d is represented by 100, and there is no way to differentiate the number 100 and a lowercase d except for how this is interpreted by the computer. And so because we're printing here in this function, it interprets it differently, but there's no way to differentiate the two. So if you were looking at the numbers. So is everyone tracking pretty well? Explain int. What specific questions do you have about int? Int is a whole number, and yeah, we're back to inception. Int is a whole number. It can be positive or negative unless it's an unsigned integer. It's a variable, so it is nothing more than an identifier that represents a place in memory that can be changed to represent whatever number you might want. I'll check back on the questions here in a minute. So for C structure, and this will not run more than an hour, if any of you are wondering, just because I am on a university computer and the libraries this week, since finals are over, close at 5 p.m. So we will be done no later than 5. So in C, certain words and characters have special meanings and are reserved by the language, thus we cannot use them. While there are certain ways that you might be able to get away with using them, stay away from them altogether, just because it can create unintended results, sometimes catastrophic to the program, meaning that your program won't run or will have issues and you won't be able to figure out why. There is a great article about that included right here, so you can refer to that if you're looking for a little bit more information on that. But if you're not, I guess, quite that deep into C, don't worry about it. It's just refer to it to look at, there's some words and characters that you want to avoid unless you're using them specifically. So like times, you can use it specifically, plus specifically. The other ones we can get into what they mean, but you wouldn't want to create a variable name that has any of these in them, or a constant name that has any of those in them. And unless you're declaring an int variable or a double variable, which stands for which is a floating type variable. Unless you're using those specifically, you don't want to use it in a variable name. So again, review that if you're looking for a little bit more information, but it's not necessary. Just know what to stay away from. The tools we have in our belt as programmers are variables, constants, arrays, structs, functions, and libraries. And those are just a few of the tools we have as programmers. We'll get into all this as we kind of evolve over the next few weeks, but the main ones you want to focus on now are variables, constants, and we'll get into functions in the next one. Libraries we're already kind of dealing with by using functions like printf. A function structure. Functions in the C language follow general format of an identifier, parameters in the parentheses, separated by commas, and a semicolon to end the line. So there's one exception to that last one. A semicolon never follows a function definition. It always follows function declaration, a function call, pretty much everything except for just a couple of instances, one of those being a function declaration. Every line that you are putting function calls or anything else on should be ended with a semicolon. Exceptions would be when you have brackets, the function definition, end of that line, and also when you're declaring constants, certain types of constants at least, when you're defining constants. So what's the difference between a function declaration, function definition, and a function call? A function declaration is put, because the main function should be the first function that you have in your file. You still have to remember that if you have another function after it, if you try to call the function after the main function in main, what will happen is it won't recognize the function because essentially it doesn't exist yet. And so you'll get a compiler error and it won't even compile. So what you have to do then is you have to declare the function beforehand, but it essentially doesn't have anything in there yet. That is what a function declaration is. So you'll have all your functions, then you'll have function main, then or the function definition for function main, and then the function definitions for all your other functions, and then you can have function calls anywhere. So why this is important is a function declaration is not necessary if your function definition is first, because it's essentially one and the same in that instance. But if it's not first, then you can't call the function anywhere. Everyone tracking? Okay, cool. And for those that are not watching it at the time, feel free to drop a comment below and I'll do my best to get back to you, or shoot me an email, eatsleeprobotics@gmail.com. Printf and scanf are functions declared in the default C library or stdio.h, since they're both already declared and defined by default in C, declared and defined. A function declaration definition is not necessary. All you have to do is a function call. So in here again, printf, right there, this is a function call. Because we've included the library stdio.h, which stands for standard input output.h, it pulls then the function definition and declaration from inside this file. Same thing when you include files in robot C, exact same thing since it's just a derivative of this language. Then it pulls that function and looks how to interpret the things inside of there. So it sees this, it sees that there's this string, pulls that, this series of letters and characters, and it sees that %h, percent is, as we saw in here, percent is one of the special characters, so it knows at that point that it needs to do something. Sees percent and C. C stands for character, and so this means that it's going to, in the order, because you can have multiple of these, you could have %C, %D. So you could also then have, actually I'll get into that in a second. It knows that it's going to put whatever, since there's only one percent sign, that it's going to replace this with whatever the first parameter after it is, or Z. So what if we wanted to say x times y, but the values of them? What if we want to say 10 times 10 equals 100? So we'll change this back to interpreting this as an integer or %d. So execute and run. X times y equals 100. And let's say that we want to also then represent that. So we represent x and y. We can swap this out with %d times %d. Let's try executing and running this. Now, if you notice, you get z here, which is 100, times then this very large number equals 0. Now, the reason this is like I said, there's physical places in memory. Because it is looking at z first, it still is there, and for some reason it's going to then go to the next place in memory and then the next place in memory, which just happens to be random values. So if we wanted to then change it to say 10 times 10 times 10, or 10 times 10 equals 100, we can do x, y, z. So this is the first parameter. It looks at that in the function and sees how to interpret this and then display this. It knows to replace %d with then variables following this as other parameters. X can get pulled into this one because it's the first one, y into the second one because it's the second instance of %d, and z into the third. So if we execute and run, sum of 10 times 10, which would be wrong, so I guess we should say product of 10 times 10 equals 100. And if we change this to say 100, let's say, you can then see product of 10 times 100 is 1,000. 10, so the first instance of %d is x equals 10, 10, so it did exactly that. Then times %d, second one is y equals 100, so 100 equals %d, third one, now that we're the third one of those, is z equals x times y, 10 times 100 is 1,000, so it displays 1,000. Which I guess it should be careful to know. All the math is happening on this line. Especially people that are newer to programming might think that because we have something here that somehow math is taking place here. Nothing is happening there. We could, again, only have one parameter like before, and we could change this to say something like I am 1,000, I am %d, whatever that value of z is, I am years old. If we execute, I am 1,000 years old. So the only thing this is doing here is displaying what you tell it to display based on the parameters of that function call. So is everyone tracking pretty well? Awesome. Awesome, awesome, awesome. So this here gives you just a little bit easier way of seeing how this all works. That there's the identifier, the parameters, which are contained inside of those parentheses, what each of the parameters are in these two examples. And yeah, that gives you a little bit better idea. So I guess one other thing we should real quick do, since I never actually covered scanf. Scanf is very similar to printf. It's just instead of printing something, it reads in values. So again, this is moving very, very quickly, but according to our course pre-evaluation and interest survey, everyone has at least or the majority of the class has at least a little bit of experience to the point that I don't believe we're moving too quickly here. So if anyone is having issues, again, I'm more than happy to help. Also, go check out all the resources I have provided for you, and then I will do my best to make sure that everyone is understanding what's going on, because I do want everyone to be as successful as possible. So I will real quick put together a quick program that uses scanf and printf, and this will give you a good example of, I'll post later the first assignment, and it'll be just a simple scanf, printf The assignments will be they will cover a lot, so there may be things that we didn't cover in lecture or in the material. And so part of the reason for that, which I know I hate when this happens in classes that I take here at university or whatever, or in high school, I hated it too. But if it's something, because we're using all virtual resources like Google Docs or whatever, if you search for it first. If you don't find something right away, Google. Stack Overflow is a great resource. You do have to sift through and make sure you're looking at something that answers your specific question. Um, but that is a very valuable skill to have as a student and as a programmer, to be able to find issues that you're having and very quickly find a solution to it. So that's kind of part of what I'm trying to teach in this class also, is learning how to, when you do come up with something you're not sure what to do, I'm trying to also teach and instill the ability for you to handle it on your own and not be so, preoccupied with finding the answer in the book or whatever. Just like robotics, like if you want to build a robot, it's up to you to come up with an idea. It's up to you to come up with a design process, a notebook, all that. It's all done on your own. Same with this class. There's going to be things where I want you to kind of explore on your own so that you can learn a whole lot more. Because honestly, that's how I learned how to program. I just learned a lot by Googling. That's how there were labs this year for CS where I was taking C programming again this year, a higher level, and there were labs where other people were not able to figure out stuff from the book or whatever, but I was able to figure out different finer points in the lab just from Googling, finding some good information, and then being able to complete the lab. Just again, just because this is a very valuable skill to have. So to get back to this, one other note is, as we are coding, I want everyone to practice commenting, even if it feels pointless that we're commenting some of the stuff. It's a great skill to have, especially when you're coming into other people's code. I cannot tell you how wonderful it is when you actually understand the code and you don't have to spend 3 or 4 hours trying to read other people's code and understand it because it wasn't documented well. If you don't believe me, you'll eventually hit a point where you wish someone else had commented. So the two different types of comments are, this is a comment for the remainder of the line. And this is a multi-line comment. Int comment is over. And I can even illustrate that further because green is a comment. Int comment is not over. You can see this is highlighted green and it won't do anything. So I'll leave that in there just as a quick note for that. Actually, real quick copy, and then I'll save and post that somewhere later. So let's create a program that real quick, you put in the user's name, or you put in the user's age, and it figures out the year that it's born, or that the year that the user was born. So we'll use scanf, printf, and a little bit of basic math with some variables. And it will be a great first project to demonstrate some of these principles, and then you'll get to start exploring on your own this week. Like I said, we're going to wrap this up very quickly, so less than 8 minutes left. If you're getting a little antsy, don't worry about it. The end is near. So let's real quick create an int for user years old. You notice there's no initialized value, which means that currently wherever it is determined this is in memory, whatever the old value in that place currently is, that is the current value for that variable until you assign it. So if you were to then initialize it instead as equals 0, now it will equal 0 because it said that that identifier, that place in memory, is now equal to 0. So let's create a constant. So the constant will be created outside of the main function. And just like the example here, where did I put it? Oh, yeah. Examples of constants here would be hashtag define, the identifier, and the number. So let's do hashtag define, and this should be all caps, current year. You don't have to do an equal sign or anything else, just a space. Put in there 2017. Let's now say, so int user years old, so stores the user's age. Let's now also then do int, because we said we're going to try to find the user's year of birth. Let's say user year born. And because we don't have a value for that yet, actually a value for either of these yet, we don't have to worry about them quite yet. The scanf function, like I said, is very much like the printf function. You have scanf plus then the parameters of that function. So let's do, again, like in the, I believe I put it in here. There's also other things you can put in scanf and printf to be able to, yeah, here we go. So backslash n backslash t, that means new line. This means tab. So scanf and printf are separate. This means you cannot mix the two. There are ways to kind of use functionality from each against each other, but they're still very separate. So for this, please, let's put this on a new line. Please enter your age. So it's going to print this, and at the end of it, then scanf begins. We'll put here a quick %d because we want them to enter an integer, since this is an integer data type. And then comma, because that's the first parameter. The second parameter then will be user years old. But because, so as we said, there is, every identifier has a place in memory, right? And that's where the actual value is stored. The identifier is nothing more than referencing that. So because we have to go to that address and change whatever's there with this, there's something called an address operator, and that is the ampersand sign. And so what that means is it's going to put whatever is in here wherever the address of this identifier is. So it'll find that address, that place in memory, and then it'll put in whatever the user typed. So let's just to test this, put in then printf user years old. And the reason we don't have to put the ampersand or the address operator there is because we're printing the value of this and not instead writing to that address, where it will just give us whatever the value of that identifier is. The user is %d years old. So let's real quick execute. My bad. Missing a semicolon. I might have to put, oh, we'll say 13 years old, or I'm 19 years old, so we'll say that. Execute. Okay, please enter your age. It entered this. The user is 19 years old. So if we wanted to then say print f the years born, then we'll say that user year born is equal to 2017, even though it's almost 2018, minus then user years old. And then put this on a new line, \n. We'll put this on a new line as well. You were born in %d, add an exclamation point just to make it more emphasized. So we'll then put user year born as the parameter that references, semicolon, make sure it doesn't error, execute the program. Please enter your age. It then pulls this here. This is not exactly a strictly command line. Actually, let's try this. Let's try this again. Interactive mode is very slow. I liked it better when it was off. Difficult. I'm 19 years old, like I said, and let's execute it now with the inputs. The user is 19 years old, and you were born in 1998. So this is all correct. The only thing is just that it's a little bit glitchy with the inputs. That is not C. That is just this. But it does give you a very good idea of an introduction to this concept of identifiers, address, memory, all of that, and the basic printf, scanf functions. So real quick, do we have any questions? We're exactly at 1 hour. Thanks for everyone who tuned in, and also to everyone watching on YouTube. If you enjoyed this video, please do give it a thumbs up, like, comment, share, subscribe. I thank you so much for watching. Share with anyone in your club that might find it useful. Do subscribe, and I will see you next time for the next lecture.